Hello, and welcome to the section 4.2 video on adding, subtracting, and multiplying polynomials. We're going to start off with a couple just adding polynomials. Seems kind of tricky, but all you're really doing here is just combining like terms. Look at the correct exponents, add or subtract their coefficients depending on sign. In this case we're adding. This would give us 3x to the third. We look at the x squareds, 8x squared minus 3x plus 2. That's all you got to do when they ask you to add polynomials. Same thing for the next one. We don't have an x or y to the third in the second one, so we'd have negative 4y to the third. Add the y squareds together, plus 3y squared minus y plus 11. Okay. That's all we're going to do when we add polynomials. All right. One extra step we can do when we subtract polynomials, we can change the middle sign to addition and basically distribute the negative to everything in the second parenthesis. All right, some of you might know that as keep, change, change. Keep the first parenthesis, change the sign to addition, and change all the signs in the second parenthesis. What you're really doing in that case is just distributing this negative to each one of these terms. All right, and then we do that, we just combine our like terms. So our w's to the third will give us negative 2w to the third plus 9w squared plus 2w plus 7. Okay. All right, same thing with the second one. If I distribute this negative, that'll turn to negative 7q squared plus 4q. We combine our like terms, negative 2q squared plus 3q plus 3. All right, so that's all we have to do when they ask us to add and subtract polynomials. You really need to make sure you're careful of the sign here, because if you thought this was multiplication, it could get pretty messy. All right, for the next one, when we talk about multiplying polynomials, there's a couple ways we can go about it. We can distribute everything in the first parenthesis. So 2y squared times y would be 2y to the third. 2y squared times negative 2 would be negative 4y squared. And then we would do the negative 3y plus 6y. Then the 5 plus 5y minus 10. And then just combine our like terms. So we'd get 2y to the third minus 7y squared plus 11y minus 10. Okay, that's one way we could do it. Another way we could do it is basically make a box or a rectangle here and find the area of each box. Now our first parenthesis is a trinomial, so we write each of the terms out in front. And our second one's a binomial, and then we find the area of each box. 2y squared times y would be 2y to the third minus 3y squared, and this would be 5y. We do the same thing with the second column. Negative 4y squared, 6y, and negative 10. Then you would just go and combine your like terms, which are here and here, and we'd end up back at the same answer. It does not matter which way you want to do it, it's totally up to you. I like this part just in case I forget to distribute a certain sign here. All right, but it's totally your call. You can just do the repeated distribution when we do this. All right, so I'm going to make the box method for the next one as well. So I have a binomial times a trinomial. Okay, I like to put the ones with more terms on top here. So I'll have 2x squared minus 4x and 3. And down the side here, I'll have x and 8. Find the area, 2x times x squared, 2x to the third. X times negative 4x is negative 4x squared. X times 3, 3x. 8 times 2x squared, 16x squared. 8 times negative 4x is negative 32x. And 8 times 3 is 24. If I then go through and combine my like terms, I would be left with 2x to the third. Notice we have the x squareds here. So we add those two together. Negative 4x squared plus 16x is positive 12x squared. Negative 32x plus 3x is negative 29x plus 24. All right. Once again, you could do the repeated distribution. You would get the same thing as this polynomial right here. Okay. Now what we're going to do is we're going to multiply some binomials, but not just two of them like you normally do. We're going to multiply 3 of them here. All right. What I would suggest when you go through and multiply 3 of them is pick 2 of them. Let's say we pick the first 2 and multiply them first. We can do that by repeated distribution, or sometimes the trick you guys know, FOIL, when we multiply a binomial times a binomial. All right, x times x, x squared, minus x plus 2x minus 2. I would simplify that to x squared plus x minus 2. And then I'm going to multiply that by x minus 3. Okay, I'm going to use the box method again, just because, as you can see, I like that method. X squared, x, negative 2, x, negative 3. X times x squared, x to the third. X times x, x squared, x times negative 2, negative 2x. Negative 3 times x squared, negative 3, x squared. Negative 3 times x, negative 3x. And negative 3 times negative 2 is positive 6. So we then go through, and we'd say our answer would be x to the third. Well, negative 3x squared plus x squared is negative 2x squared minus 5x, that's negative 3x, plus negative 2x, plus 6. Okay, and it wouldn't matter which 2 binomials you start with. You could start with these 2, the outside ones. It does not matter. All right. So, same thing for the next one here, except we always want to kind of take a look at it to see what we have. In this case, we know here, if we multiply these last 2, what's going to happen is the middle term is going to cancel out. So we'll have k minus 2 times k squared minus 9. We'd have k squared plus 3k minus 3k minus 9. All right, when you see the signs are the same, remember these are conjugates of each other, the middle terms will cancel out. Now we can just go through and we could do a box here, or we could just say k times k squared would be k to the third, k times negative 2, or sorry, k squared times negative 2, negative 2 k squared, k times negative 9, negative 9k, plus 18. Okay. Understand, you can do the box method for this. It does not matter. K to the third, negative 2k squared, negative 9k, and 18. Okay? Totally your option. All right? It's up to you guys. Okay? So, what we're going to talk about next is some special product patterns. Okay? So, if we have certain cases, we can go through and actually realize what's going to happen if they write this as a binomial, or our different patterns. All right, we have the sum and difference formula. That's what we just talked about here. All right, so if I said, I don't know, 2x minus 5 and 2x plus 5, all right, our A in this case would be 2x and our B would be 5. All right, and all you do is just follow this pattern at the end. So you would say 2x squared minus 5 squared, which would give you 2x squared would be 4x squared minus 25. You would get the same thing if you did FOIL these out, all right, or distribute these. Doesn't matter, it's just showing you there are shortcuts, all right? And some of you already know them. It's awesome. All right, same thing for the next one. If we said, I don't know, let's say we have 3x minus 4 squared. Remember, you can't just square each term. So we'd say our A is 3x, our B is 4, and then we'd follow this pattern, and this is a subtraction one, so we'd say 3x squared minus 2 times our a times our b plus our b squared, all right? We always just take the signs. Notice it's not changing the signs here. We just follow what they give us. So this would give us 9x squared, negative 2 times 3x is negative 6x, times 4, all right, is negative 24x, and 4 squared is 16. All right, once again, if you just distribute these, just remember that this is saying it's times itself. It does work, all right? It gets a little bit easier, and it saves us time if we remember this pattern when it's the cube of a binomial, okay? So now we're gonna multiply this thing times itself 3 times, all right? You could do the same thing as up here. I just think it's easier if we go through and remember this pattern. So if I say, I don't know, we'll say 2x minus 3 cubed. Our a in this case is 2x, and our b is 3. All right, notice here it's minus in the middle again. So we're gonna follow this pattern. So it's gonna tell us to take our a term and cube it, minus 3 times our a term squared times our b, plus 3 times our a term times our b squared, minus our b cubed. All right, so we're gonna go through 2x to the third. Well, 2 to the third is 8, x to the third. We need to do exponents first. 2x squared is 4x times negative 3, all right, is negative 12x squared, times negative 3 is negative 36x squared. All right, exponents first again. 3 squared is 9, times 3 is 27, times 2x is 54x, minus 3 cubed. 3 times 3 is 9, times 3 is 27. All right, I would say the cube of the binomial saves you the most time. You have seen these other two patterns before, just refreshing your memory. All right, so if we see here, for example, 5, it says 2x plus 7, 2x minus 7. That's the sum and difference. What you're really going to have, if we did it this way, is our a is 2x and our b is 7. So we would say 2x squared minus 7 squared, 4x squared minus 49. Okay, like I said, those are the ones we probably had the most work with. So we might not need to use them. We can just go through and do the multiplication here. Now this one, next one is to the third power, so we want to make sure we follow our pattern here. In this case, our a is actually ab. It's 2. It's one term, but it's 2 variables. And our b is 2. So we're going to follow this last pattern here. All right, so we would say ab cubed minus 3 our a squared times our b plus 3 times our a value times our b squared minus 2 cubed, which is our b cubed. All right, this would now leave us with a to the third, b to the third. All right, this will give us a squared, b squared times negative 3 times 2 is negative 6a squared, b squared. All right, oh, sorry, that should be a plus here. My apologies, these are all pluses. These are all pluses, so that's a plus. All right. 2 squared is 4 times 3 is 12, so this would be plus 12ab plus 8. Okay. All right, same thing for the next one. All right, your a is 2y, your b is 4. All right, I'm just going to kind of do this one down here. We use plus again, so we would say 2y to the third minus 3 2y squared times 4 plus 3 2y 4 squared minus 4, sorry, plus again. What am I doing here? These are pluses. Notice this sign here, those should all be pluses again. My apologies. We go through and do this. We should get 8y to the third plus 48y squared plus 96y plus 64. Okay. Can save you some time, just something else you can realize moving forward. All right, some applications of this stuff. All right, so it says the picture below, all right, and then you have this in your class notebook, but the picture below is a blueprint of the first floor of a house. The 5 rooms, the bedroom, living room, dining room, kitchen, and bathroom are quadrilaterals and have polynomials describing the length of the sum of their sides. Each length is in feet. All right, use the figure and your knowledge of polynomials, perimeter, and area to answer the following questions. All right, so we're going to perform the given operations and simplify the expression completely for each of these. All right, so the first one, what they want us to do is take x plus 2 here. Sorry, I'll move this up so you can see it. They want us to take x plus 2 and add it to 4x minus 1. Well, if we add those things together, that will give us 5x plus 1, and just remember our units here, feet. Well, what does that represent? Well, if we look where x plus 2 is and 4x minus 1 is, this would be the length of the side of the house. All right, this is the backyard, this is the front yard, all right, and that's just the side of the house. Okay. Next one, what they want us to go through is just add 3 terms in this case. So we want x squared minus 16, or 3 different terms, or sorry, 3 values, plus x squared minus 6x minus 16. So if we add all these together, we add our x squareds together first, which would be 2x squared. Then we add our x's, minus 5x. And now we add our constants, negative 32. All right, that will be feet, that's a dimension. But notice in this case that x squared minus 16 and x squared minus 6x minus 16 are the dimensions of each of the rooms that make up the backyard. So this here would be the length of the backyard. All right, so it's basically taking what we know about polynomials operations and adding them into some application here. All right, if we look at example 3, they're saying 2 times 4x plus 1 and 2 times 4x minus 1. If we distribute the 2, we'd have 8x plus 2 plus 8x minus 2. Add our x's, 16x. Our constants cancel out. We're adding here, so it's in feet. Well, if we look here, the bedroom is 4x plus 1 by 4x minus 1. All right, and if we look at it, they're adding these 4 sides, so this is the perimeter of the bedroom. All right, if you think of perimeter, 2 times the length times 2 times the width. Okay. Our next term, our next question is 2x times x squared minus 16. All right, so we'd multiply these things and we'd get 2x to the third minus 32x. All right, now we're multiplying, so this would be feet squared or square feet, no matter how you want to write it. All right, and if we notice here, that's the length of a value times the width. So what we're really here is the area of the kitchen. Right, so we're kind of also taking what we know here and applying it back. All right, so what we're going to do now is example 5, and they want us to take 2x squared minus 5x minus 32 and multiply it by 5x plus 1. Well, if we multiply those things, those values that we have there seem pretty familiar. It's actually the length of the house and the length of the backyard. So what we're really going to do here is find the area of the first floor. All right, you guys know that I'm probably going to do the box method here. All right, so I'm going to make a box. All right, this will be 2x squared minus 5x minus 32, your 5x and 1. All right, 5x times 2x squared 10x to the third. 5x times negative 5, negative 25x squared. And 5x times negative 32 is a negative 160x. All right, one easy multiplication here. 2x squared minus 5x minus 32. All right, so we would get 10x to the third minus 23x squared minus 165x minus 32 feet squared. All right. Now, what does that represent? Sorry, the area of the first floor. All right. How would we classify your simplified polynomial? Well, classifying it, we're going to look at it. Well, what's the highest exponent? It's to the third. So this is a cubic polynomial. All right, just to kind of review from what we did in the previous section. All right, so I'm running out of room here, so I'm just going to kind of do this on add a little piece of paper. All right, it says if x equals 2 and y equals 4, find the area of the living room. All right, be sure to include appropriate units of measure. So if I look at number 6, if I go up here, the living room is x minus y, or sorry, xy minus 3, and I would multiply that by xy plus 3. All right, so I took those values, the dimensions, all right, and I did this. So what I'm going to do is I'm going to plug in my x and my y. So I'm going to say 2 and 4 minus 3 in the first parenthesis, and then 2 times 4 plus 3 in the second parenthesis. So we'd have 8 minus 3 and 8 plus 3. So we'd have 5 times 11. So we would get 55 square feet, okay, or feet squared, all right? So that's the area of the living room, all right? Thank you for watching the video. Your homework will be posted soon. Please let us know if you have any questions. Have a great day.